Chapter 14, Question 4 is asking you to give the IUPAC name, that's the name using those rules in the table on the right, for some compounds. So, in this one we don't have a branch, so we'll just go prefix, infix, suffix. The prefix depends on the number of carbons. Here we only have one carbon, so the prefix is going to be meth. Then, outside of the functional group, we only have single bonds. This is the only bond that's outside of the functional group, and it's a single bond. So, if you have all single bonds outside of the functional group, the infix is AN. Right? Any double or triple bonds that are in the functional group will be represented by the suffix. The suffix represents the functional group. So the rest of this represents the functional group, this right here, and that functional group is a carboxylic acid, a carbon double bonded to an oxygen, single bonded to an OH. And the suffix for carboxylic acid is oic acid. So the name for this molecule is methanoic acid. You wouldn't have to put in a number anywhere, first because the carboxylic acid is always on carbon 1, and second, because there's only one carbon in the whole molecule, so you know exactly where the functional group has to be anyway. So methanoic acid. Methanoic acid is the IUPAC name. There's also a common name for this, which is formic acid. Formic acid, this is the acid that red ants inject under your skin. All right, this is asking for the IUPAC name for the following carboxylic acid, and what should really stick out here is that you have a 6-membered ring with alternating single and double bonds. When that happens, that should stick out, and you should say, oh my gosh, that's benzene. If you have a functional group coming off of benzene, then you have a benzene derivative, and benzene derivatives have their own common names that you wouldn't be able to figure out using the IUPAC system. So in this case, we have a carboxylic acid coming off of benzene, and that has its own common name. It's called benzoic acid. So that's going to be the parent chain here. If you ever have a benzene derivative, the benzene ring and the functional group together act as the parent chain. So the name for that parent chain here is benzoic acid, and there's no way you could have known that except by having been exposed to it and having memorized it. That's true for all of the benzene derivatives and for benzene itself. So once you have these benzene derivatives, if they have another branch on them, you want to number them from the functional group that creates the benzene derivative. So here I'm going to start numbering on the carbon where the carboxylic acid is attached. No matter how I number, I get the same, whether I go clockwise or counterclockwise, I get the same number for the branch. So I'm just going to go clockwise. And the branch, as you can see, is on carbon 4. Always between numbers and letters goes a dash. And this branch is Cl, that's chlorine. Chlorine is in column 7A on the periodic table. That's the column for the halogens. And if you ever have a halogen, you just take that first syllable, so chlor, and then add an O, and that tells you that it's a branch. So that's the name of our one and only branch. To get the whole name together, we'll take that branch name, put it in front of the backbone name, and the full name for this molecule is 4-chlorobenzoic acid. All right, now this one has some branches, so first let's try to figure out the parent chain. The parent chain is the longest chain you can find without lifting up your pencil or going backwards. That includes the functional group. So here it has to include the carboxylic acid. So let's try a few. Maybe it could be 1, 2, 3. Another possibility could be 1, 2, 3, 4. Or another one could be 1, 2, 3, 4. Looks like the longest I can find, no matter how I go, is 4. So it's definitely not this blue one. The green and yellow ones are both 4. They tie, so either one will give you the right name. I'm just going to go with the green one. So that's our backbone. I'm going to circle that so that it stands out and so that the branches are distinguished from it. So that backbone has 4 carbons, and the prefix for 4 carbons is bute. In the backbone, between the carbons, are all single bonds. It's true there's a double bond to an oxygen, but that's part of a functional group, which is going to be represented in the suffix. So here there are all single bonds between the carbons, so the infix is AN. The functional group is this carbon double bonded to oxygen, single bonded to OH on the right of the molecule, and that's a carboxylic acid. So the suffix for a carboxylic acid is oic acid. So this is going to be a butanoic acid. Now for the branches. Our first branch is coming off of carbon 2. Always between numbers and letters goes a dash. The branch on carbon 2 only has one carbon on it, so the prefix is going to be meth. And because it's a branch, a carbon branch, immediately after that prefix comes YL, so 2-methyl. On carbon 3, we have another branch. Always between numbers and letters goes a dash. On this carbon, in this branch, there is only one carbon, and so the prefix again is meth. Immediately after that prefix, because it's a branch, comes YL. Now we have two branches that are the same type of branch. They're both methyl branches. So we can smush these two together. Take the two numbers and separate them by commas, 2, 3. Always between numbers and letters goes a dash. You have to say how many branches you smush together. In this case, we smush 2 together, and so the prefix is di. It's a very common thing for people to forget, that di there. And then we have to say what type of branches we smushed together. They were methyl branches. So the name for those two branches smushed together is 2,3-dimethyl. Last but not least, we just take the branch names and put them in front of the backbone names. So there we go. And then the full name of the molecule of this molecule would be 2,3-dimethyl butanoic acid. 2,3-dimethyl butanoic acid.